Oh, stop using AIs back. You know, you've come to the wrong stream. Stop using AI. I'm going to use AI today. Sorry, stop using AI. But I'm not... Is that okay? I won't do it. Well, I know I will. Probably will do it anyway. But yeah, I thought basically... Oh, okay. Here we go. Yeah, I thought today that I would use it to generate some some algebra questions for me, just to get me warmed up, because there's a big algebra problem that I'm not doing very well. Yeah, okay. Only use ASCII, please. So there's some inequalities, basically. There's some inequalities I need to solve. And I don't even know what that is. Stop using AI. There's some inequalities I need to solve. So I've been revising. Actually, I haven't been revising. I've also, you know what else I've done? Look at this. Check this out. This will save the environment by making my laptop heat up less. Nope. 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 Okay, here, wait. It's gonna happen. Okay, it's happening. Okay. All right. Here we go. Here we go. I can type now. It only took me like months to get us to decide to implement any sort of text input beyond handwriting, but now I can type, which is going to stop me from being really lazy. That's accountability. That stopped me from being really lazy and not writing things out. So here's the problem. We're starting real simple, and then hopefully it's going to get more challenging. And I'm going to... So I have been doing a little bit of this just to see whether any of this works. And so far it does. Hello in a climb bottle. Starting early. I guess so. I guess it's a little early. I considered stopping in the morning. Starting in the morning, I should say. Because it was cooler then, but I didn't. I didn't do it. I didn't do it. How are you doing in a Klein bottle? Can I call you Klein? Okay, so I've done like 4 of these, and basically they all kind of go the same, right? Which is you collect the terms. So one thing I've been doing a lot of, as real K fans will know, is I make all kinds of mistakes all the time with the detail of these. So I remembered when I was studying at school, you had to write everything out. Didn't help my teachers much because they couldn't read my handwriting, but let's try that today. 11 minus 5, that is 6. And so we've then got... Oh, and by the way, everyone, it's a real treat for you today on stream. This is Arctic. I've brought some Arctic noise to cool you off in case you're in Europe. And you're melting rapidly. Yeah, I'm also melting rapidly. But this, I saw a kids' TV program once where they said that if you just imagine you're in a cold place, it helps. So we're imagining that through the Arctic. Yeah, no penguins. Aren't they in the southern hemisphere, or are they? I can't remember where they are. I've never seen one, so they must be in the southern hemisphere, right? And there's some in Argentina, right? Anyway. 42 times 67 would take you 3 minutes to solve. Okay, let's try it. Okay, time me. It's 4:04. Hello, Naimir. How you doing? Good to see you again. After I saw you earlier as well. Okay, 67. Does that go on that side? I forget. Okay, 2 times 7. That's 14. 4 times 6. That's 12. 24. Oh yeah, you got to cross these out too. 254. Is that right? Is that right? Is that right? No, it's nowhere near right. What about? I don't even know what I'm doing. Terrible. How do you do this again? Okay. All right. 42 times 6. Yeah, obviously it's not that. Okay. How do you do this again? All right. 14. So that's 14. I guess you have to take account for the fact these are both 10s. So you end up having 2, 4 over here. 24,000. 40 times 60 would be 24,000. And then it's that. Is that right? 281. No, still wrong. Closer though. 28. It's 28 is what it is. Okay. Well, there you go. There you go. Oh, you got to multiply them out. Oh my gosh, you got to do all that. Wow. I cannot remember anything about how you're supposed to do that. So, Coding Bar, if you're cooked, I'm cooked. We're both cooked. And we could both be cooked, honestly. I wouldn't be massively surprised. Yeah, I mean, I've been using AI to do a mental arithmetic for since I was a child. And when I say AI, I mean the calculator. All right, Klein's teaching us. Okay, 2 times 7, carry the 1, 40 times 7. Right, okay, so you got to do them both. I guess it's just like normal algebra in that way. Okay, okay, let's try this again. Oh no, wait, there's like a whole thing you do, isn't there? Oh yeah, you like take them, you go like this, you do this, and then you do 4 times 7, which is 28, right? Yeah. And then you move it along like this, and then you do 2 times 60, which is 120, and they do 40 times 60, which will be 2 this, right? I think. And then, wow, I mean, okay, we really are going back to basics today. 3 plus 8, 11. 5, 7, 8. Oh my gosh, it's the right answer. Wow. Okay. Wow. Yeah, Klein, that's a nice way of putting it. Like the algebra. Wow, this is this ducking annoying anywhere else? Anyone else? Yeah, I think it's annoying me. Does it annoy anyone else? I think it sounds alright if I'm... Sorry, I'm just listening to myself in my own microphone. I think I can turn that off, probably. I don't think it gets too crazy on the audio today. Alright, is this better? Hello? Hello? No, let's just get rid of that. Okay, I think that'll be fine. Mathematicians are famously not fast at doing arithmetic because we don't do it all that often, but we do know the tricks. Yeah, that's what they told me when they were trying to make me do this stuff at school, I guess. Well, they told me after a certain point. Oh, also, I can do this now. Look at that. Incredible. And I can do this. I can do this. Look, watch this. I made all this today. Or yesterday. Anyway, what was I doing? Okay, 6 over 3, that's 2, right? Right, what does AI say? You know, it does help a little too much. Also, it like gives you the answer in the... It's not very good at... Claude Code not very good for this type of thing, because it gives you the answer just immediately. Hello, Happy Nora. How you doing? Yeah, this is Claude. Claude likes to be a bit silly. Amos says we do it a bit differently in Soviet math school. Do you? Yeah, there's like a whole, there's a whole thing about how different cultures teach this stuff, right? Like, I don't know. I guess I assumed because mathematics is surrounded by this aura of like objective truth. You sort of just assume the way you're taught at school is like objectively correct, but it's just not that way, right? Because they did a whole new math thing, right? That's what Tom Lehrer did the song about, where they just sort of taught it totally differently. Yeah, I'd love to hear more about that. Hey, it's hard to type. Okay. Yeah, fair enough. Fair enough. Fair enough. Somebody said fair enough to me yesterday, and I was like, in my mind, I was like, did I upset you? Because I don't know why I say fair enough all the time, but somebody said to me, I was like, oh my god, did I say something wrong? Just talking now. They say when you're streaming, it's best to just talk nonsense. But that's why streaming fries your brain. Okay, subtract 7. Alright. And we got -6, and then we got to do this thing. We got to do this thing. This is the thing that I didn't have so much facility with. Let's say we want to divide by -2. We've got to flip it around. Then we get this. And I guess we get -6 over -2, which is going to be 3. Klein says, there is a fantastic comment in a textbook translated to English about how the word amenable has a fun double meaning in Russian but doesn't translate at all to English. Huh. I love it when textbooks do that kind of thing. Okay, well this is what the AI autocomplete said also, so that's quite good. My laptop's already heating up. I need like a temperature thing for my laptop, honestly. Okay. Right, now we've got this. We've got a new one. You know, funnily enough, here's a fun thing. One of the problems with using language models for anything like educational material is that they find it very difficult to conceal anything. So they like to tell you the answer a lot. They really want to tell you the answer. There are some models that don't do that, but it's quite rare. Okay, what am I doing? Let's +3. And then we've got... oh yeah, we've got something on the other side. +12. And then let's minus an x. And we've got 3x. 12, less than 12. And then we've got x. 12 over 3 is 4. Yanchifim says, my impression is that streaming is all about making your inner monologue an outer monologue, no matter how insane. Aha. That's an interesting idea. Sorry, inane, you said. And Klein says, I don't think that's a fair assessment. Even the most immature streamers are actually quite skilled at interacting with their audience. Yeah, I saw some advice which was something like you should, even if you have no viewers, you should just talk to them, which I find very funny. It's like if you're creating a TV show comedy about streamers, that would be one thing you would talk about, I think. It's like really depressing. It's really depressing. It's like yeah. Did I say what model? This is Opus 4 point something 4 point whatever 8 maybe. I don't have, you know, I did try Fable. I tried Fable a little bit. And I got that horrible feeling again, like it was I hate to admit it, but Fable is pretty good at a bunch of things AI has not been good at until recently, which is kind of took me about a day to get over, because it was good at some aspects of my job that until then no one had been good at, or no models had been good at. So I had to reckon with that a little bit. Indeed, Fable is forbidden. Fable they took it down. It was too powerful. Too powerful for Europeans, and also anyone in the US. I don't know if they introduced it again for US residents or not. S-Destroyer, hello. Yeah, AI Algebra today. Not for the whole stream. That would really hurt. Yanchi Film says, I'm being a little flippant, of course, but the biggest barrier most small streamers, stroll memers, have to get over is dead air when there aren't many chatters. I bet that's why most people get stuck. Yeah, you got to really, it's a bit like being an actor or a teacher or any presentational, or a manager, honestly. Well, depending on the kind of manager you are. Any public, any outward facing role, you just got to be kind of comfortable just being a bit foolish, because if you're not, it like gums you up, right? Even if you're never foolish, even if you hypothetically were never foolish, the fear would see, I don't want to be recapped. Why won't software do what I tell it to anymore? It's got a mind of its own. Hello, Lorseya. Hello, RPC 2.0. Good username. Yeah, indeed. Where'd the data come from? Klein says radio hosts in the UK can have no more than a few seconds of dead air or they lose their broadcast licenses. Wow. So if I did this, how is it? How many people are still here? 28? 28 to me. Twitch lies about that kind of thing. Alright, where was I? Okay, we got a new problem. We got a new problem to do. It's a busy day on Twitch today, or at least it was earlier. Everyone was streaming. Stian was streaming. Shout out to all the Stian stans in the chat. I know you're here. Is he still going? I don't know if he's still going, actually. He might be. It might be too late for him. Yeah, he Stian today told me I should write this board software in SDL, which I'm not going to do. I'm not going to do, but would be a cool project. It would be a cool project. He is. He's going. Oh no, I'm competing. Just go and say hi to him in the other window. All right, where were we? So I've got this thing now. I guess this is really 2 ones. Is it 2 inequalities? Is that? Maybe we can split them apart. I've never actually successfully solved anything like this before. So if we had this, let's call this a 1. And then we've got... Oh, so cold in here, isn't it? Don't you think? So cold in this stream. Wouldn't you say? Ooh, room. I think I might put a jumper on. 41 degrees C. Where are you? Are you in hell? It sounds like you're in hell. That's so hot. Oh my gosh, where are you? I'm sorry. Are you in a country that at least has air conditioning? Everyone in the UK is talking about getting air conditioning now. We're all becoming Americans. And even me, I honestly really could go for it. I really could. Okay, so let's start with 1, I guess. I guess we start with 1 and then we have a look at it. So let's take this. Oh, that is so much fun. I'd have had to. I can't believe I was writing things out manually the whole time. Okay, +1. We get rid of that. No, come on, don't be lazy. Don't be lazy. Okay, and then this becomes 4. Alright, and then we can... And I need a haircut too. That's the worst part of it. Okay, well that's as simple as I can get that. France, Paris area. Aha, that's cool. Apart from it, it's not cool, obviously. Do you watch any great French streamers, RPC 2.0? Do you watch any good French streamers you could recommend? Not that I would suggest anyone here do this, but it's kind of fun to hang out with streamers who don't speak the language you know, because it helps you, I think you focus a little bit more. How are you doing, Happy Nora? Yeah, haircut. The difficult part with the haircut is it's half an hour away from my house. Yanchi, every summer I think of it getting AC and then decide to wait until winter when the price goes down, and every winter I forget. Yeah, we don't need it in winter. So yeah, you're slowly melting like the snow in the sound bed today. You follow at least one German streamer. A good one you'd recommend? One of the fun things about being a streamer and having to deal with all of the interfaces involved is that quite often Twitch will tell me to gift a subscription to myself. It really wants me to do that, and it likes to pop up on my screen like 100,000 times an hour. Maybe I'll do it. Okay, +1 and divide by 2. Wow, even my hands are sweating. They're getting my board all wet. Terrible. Okay, so I guess then we get -2. That maybe? Yanchi Film says she's a Silk Song speedrunner, so I suppose it depends on your stream interest. Most of the streamers I follow are not coders, mathematicians. Yeah, that's cool. Pog. Yeah, I don't have all the emojis enabled on this on OBS. RPC says I watch mostly nerdish streamers, mostly NA. Yeah, nice. Oh yeah, LCO Long. Yeah, I know that one. Anyone watching Stephen Wolfram on the regular? North America. Aha. Yes, of course. Sorry. Brain not work. Then maybe we go to a pool and not come out. Fair enough. You must have AC then. T2SD is of course he is, yeah. Yeah, true actually. Nemo says, no one streams in my native tongue. I watch some Russian streamers. I suppose Soding is, if that's how you pronounce that, Soding is, he's Russian. Or at least he talks about Russian things fairly often. So I guess he probably is. But yeah, not in Russian. Except when he's really mad at chat. Which is every stream. Every stream. Okay. Alright, let's see. Okay. Right. Right. Okay. Again, get ready to have your minds blown if you're used to me painstakingly handwriting everything. I can even move it around. Oh, so cold. So cold in here. Soding's another red programmer I follow. He's fantastic. He is fantastic. Yeah, he's got a real good thing going, and he's got a huge following too, which is great. It's just kind of well, you kind of obviously he's great, but I wonder how he managed that. I guess he's been very, very consistent for a long period of time. But you wouldn't think that hundreds of people would want to watch someone do, like, the kind of programming that he does. But they do, they 100% do. Like, he's got a great audience. He designed a language called Dick in Russian. Aha. Happy Norris says he sometimes says Poggers meine Freunde, which is neither Russian nor English. That's true. That's true. I guess he could be from wherever that happens. Okay. What am I doing? Oh, somebody's coughing. Somebody's coughing in the audio. Right. So solve for y in terms of x means we want to put the x's this way. So we can add 3x. No. Okay, and then we want to divide by 2. That's going to be, don't try and do too much at once, K. So that's going to be 4 here. 3x over 2. I think. Doesn't seem very satisfying. But maybe it's not. Anchifim says he seems to stream almost every day, plus upload to YouTube, and I suspect a lot of what Twitch rewards just consistency. Well, yeah, indeed, life rewards consistency. It's a real hard lesson for me. Yeah, real tricky. So I think this is, I mean, who knows? I mean, also the AI can get this wrong, can totally get it wrong, right? So we can't believe it. We can't trust anything that it says. But let's trust that. Right. I made up that problem as an example, I think. I don't know whether it's I don't know what the solution is. I just made it up. So this will be interesting. You're a cogitator, Happy Nora. Whoa, that's enough. No answers, please. Okay. We've got y equals 2x plus 1. For which values of x does x plus y greater than 1 hold? So I guess we're saying here we treat this as like a simultaneous, I guess, inequality, not equation. So we could do this, and then something. I guess we could substitute in the y. Maybe that would work. Maybe we'll find out what that gives us. Hello, Kiara. Okay, the fact that you have the energy to stream, let alone stream mathsy proof stuff in this heat is hashtag amazeballs. I'm wilting just watching. Yeah. It, well, we'll see how long it lasts. I'm stood up, I have a fan on, I'm putting cold music, cold sounds in my ears. Unfortunately, all of my devices like to heat up. You wouldn't think that normal human energy would do that, but they do. So my hands are quite warm. We can eliminate 2 1s at once. Oh, that's true, actually. Good point. Okay, so we've got 3x greater than 0. That's 2 operations at once, but I think it's fine, as we subtract 1 basically. And then, well, we've got this. So that maybe? So this, for those of you who don't know about this AI device, this is a whole system that's it's been geared up, it's been trained, it's been oriented fully around the task of writing software, and I'm just forcing it to do something wrong, forcing it to do something else. Whole thing. How many degrees I have? Yeah, I've got 31 degrees. I think. Let's refresh this, see if it's changed. 33. Can I refresh this like periodically? No. No, I can't. Need much. By the way, did anyone notice? Has anyone noticed anything different about the stream today? So much is different. Obviously, nobody tunes in to these things because they want to hear about streamer nonsense. But I've got a new keying setup. I'm using OBS now rather than whatever I was using before. I technically could do 60 FPS, but I'm not. But for some reason, I'm at like a really crazy bit rate. I'm at like a 12 megabytes a second or something. And I didn't do anything. I didn't want that. New sound, new everything. 34 in Oxford. Yeah, we're breaking Atom Fighter. Hello, new sound. Yeah. Yeah, it's probably hotter in this room as well. Yeah, we're having a very hot June in the UK. We're breaking all kinds of records. Makes you proud to be British, especially with the World Cup on. Maybe that'll help. Okay, so we've got something new. We've got answer is a range. So we've got this. -1. And then we've got x plus y. We've got this. Yeah, and then we're going to do something about this. So we could try the same thing as before, substituting in for the y. Don't know what I did there. Then we can... I think the thing we do with this is we try to make it 0 on the right hand side. So we do this. I'm just guessing. Yeah, because we're subtracting 1 here. Somehow we're allowed to do something with this. I guess. I think there's some technique which is used in these. There are a number of techniques used in these situations, which I don't happen to remember them, but I can see if I can guess what they are. RPC2, you're going to win the World Cup. France for the win. Atom Fighter, you got mosquitoes. I've been reading about, you know, here's a French thing. I've been reading about tiger mosquitoes. I think they're called that, the tiger mosquitoes. Maybe we're a little loud. I'm redlining, and I'm not well, I guess I am headlining. Yeah, tiger mosquitoes, apparently. Apparently they're the next big thing coming to the UK from the continent. So apparently they're a pretty big deal in France right now. Maybe that will help with the World Cup in some way. All right. Anyway, so people are saying things in the. It's from Asia. Okay. Yeah, but what isn't, right? Spaghetti. All kinds of stuff. All right. So I feel like there's something you do with brackets in this situation. Somebody said completing the square last time. Now, so if we want to make a, I don't know if we have an extra term in there, but we have like, we have completing the square is the wrong thing to do here. Okay, okay, good. Okay, well I won't do that then. Factorizing is the thing where you do this. Is that right? Yeah, they've been around for a while. They sting hard and make noise, really annoying. Yeah, that's what I've heard. Okay, all right. So now I need to work out. Okay, so vaguely remembering, it's a -2, which means we have to have 1 minus and 1 plus. And then we've got a, I guess we could have +2 and -1 here. And then we'd have, if we expanded this out again, we'd get x squared minus x plus 2x minus 2. And then that would be 1x. Which is what we want. I think that's right. Now, this was never very satisfying for me at school because I was like, you just guess? You just get the numbers? You just draw the rest of the fucking equation? But, you know, I guess it's pretty convenient if you can do that. Okay, anyway, so if you don't know about tiger mosquitoes and you're in the UK, here's the public service announcement. If you get stung by a mosquito and it really hurts immediately or very soon after, and you think maybe that mosquito had little stripes on it, you should call the UK Mosquito Authority. And the UK Mosquito Authority will descend on the area and they will set up monitoring and they will eliminate all the mosquitoes in the local area, or they will try. Do you think that's kind of crazy? This is a real thing, by the way. I'm not making this up. It's like, yeah, they just got a whole new mosquito action force, which comes out if there's any tiger mosquitoes in the local area. Do you learn about Vietis theorem in the school? Well, let me work out what that is. I don't think so. Definitely not by that name. Okay. All right, so we got this. Now, something, something, something. It's probably minus, you know, it must be something like this, just looking at it logically. I don't know the exact way you go back and forth between these two forms, though. InnerClimbot says, no, that thing expands to, so you're looking for A and B, whose sum is, oh right, okay. Oh yeah, I can draw the graph as well. Yeah, I can draw the graph as well. but there will be situations in which I can't draw the graph. Or maybe, yeah. Still, maybe the graph will be interesting to look at. Whoa, okay, terrible graph. My current answer is wrong. Alright, so the graph looks like this. I'm just drawing it in. Actually, I'm going to put this over here for reasons. Yeah, so we've got a line which kind of goes... Alright, excuse my awful line drawing, which will happen right now. It crosses here, here, and here. And it kind of goes like... Kind of goes like that. Terrible. Okay. So the real answer then is -2. That, I guess. So not right. I guess... No, wait. No. Well, that's where it crosses the 0 anyway. I don't know if that makes any difference. Look at where y is greater than 0 on the graph. I see. Yeah, indeed. Hello, Pete. I'm looking at it, Yanshifim, but I'm getting no insight. Right. So, what are we supposed to be trying to solve here? For which values of x does x plus y greater than 1 hold? Right, well, let's look at this and let's try and work out the real thing. So, 1 second. Let me just work out if I can use my computer at all today. Okay. Oh, it's over my head. It's all over my head. Where do we want to be? There we go. Oof, terrible key. We'll get rid of that. So, looking at this again, the question is, given this curve, that's the red one, for which values of x does x plus y greater than 1 hold? No, that is the blue area. So the correct interval, at least, will be -2 and 1. But I don't know whether it's going to be... I assume that it's not with an equality in there. People always be salty, no matter whether France wins the World Cup, which of course they will. Okay, Yanjifim says, okay, so y is greater than 0 is the upper half plane. So you're looking for x values where the curve is in the upper half plane. That's x is less than -2. And x is greater than 1. So what, the opposite of what I've got right now is what you're saying? Right. So let me think about that. X plus y is greater than 1, where... Come on. In all of this area. For which values of x does... Yeah, I think I don't even understand the question. I think I must have completely misunderstood what the question even is. For which values of x does... Yeah, okay, so we've got this curve here. This is the curve. For which values of x? Now that's all of these values along here. Does x plus y greater than 1 hold? Which will be all of the segment of this curve here. Because outside of it, because outside of this zone here, x plus y is greater than 1 doesn't hold. So we're kind of trimming off this part of the curve. And, you know, I guess there's no obvious bound on where this curve ends. So I guess it's going to be the area of... Come on. All of this area up to, well, up to here. So when we've got a curve of some kind and we're trying to work out questions like for which values of x does x plus y greater than 1 hold, or not like 100% sure on the language there, but we're combining them in that way where they do hold, where they're true together. We're looking at finding all of the area, for example, on this all of the area on this line, which, sorry, that's wrong, which contain both this shaded zone and this red line at the same time. Okay. Oof, that was painful. Let me look at chat and see if I'm actually along the right lines. Yanshifim says exactly. Okay, good. Thank you, Yanshifim. Oof, horrendous. So that still gives me the... Alright. Yanshifim has to go. Thanks for hanging out, by the way. You might want to think of y is greater than something as the region above y equals something. Similarly for below. So for example, to sketch the region x plus y is greater than 1 with that decimal, so I would rearrange it to y is greater than minus x plus 1. Sketch the boundary line and then shade above that line. Thank you. Right. Okay. Okay. Or putting it another way. Oh wow, I've got a bunch of stuff there I'm gonna have to get rid of. Just putting it another way in my head. When we're trying to solve something like this, we're looking for all of the situations where all the possible values that could be generated by y equals x squared minus 1 also have the property x plus y is greater than 1. That's a very programmery way of thinking about it, I know. But okay, interesting. Enjoy the rest of your day, Antrofim. Enjoy the heat. Okay. Namir is saying something beyond my understanding also, which is that the red graph doesn't mean much here, I think. Which I guess is true. I suppose if we were to look at it another way, we're looking at these points only. All right. Okay. Let's get rid of that for now. Right. So it remains to be seen how do we go from, aside from just graphing it, maybe we just graph it always, I don't know, but it feels like there's probably a way of going from this, oh yeah, okay. This type of thing to, well, that's wrong. Oh, there's a car. This type of thing. Right, so Nemir, it's a separate operation, you're saying? Like, the information necessary to work this out is not sort of immediately obvious from this. We have to like do a bit of extra work to find it. Okay. Like graphing it, for example. So plugging it in, for example, let's say we had x equals 3 or something. We'd be like 3 minus 1, 3 plus 2. Sorry. Yeah, yeah, that's right. So 5 and 2. 2 by 5 is 10. Okay, so in this case we know that x has got to be allowed to go above 3. So we're going to say we get this information from that. And then we could say x is minus 3, in which case we'd get minus 4 by minus 2 plus 2 will be minus 1. So we get 5 out of that, which again is above 0. So we get that x is going to be less than minus 2. And then if we plugged something in the middle of those two and said like x equals 0, then we would end up with minus 1 times 2, which would be minus 2, which is less than 0, therefore not You know, not in that area. Okay, interesting. Interesting, okay. Yeah, I guess there's probably other ways to do that I would benefit from learning. Okay. Cool. Oh. Right, let's do this one and then we'll go back to go back to that problem that I got stuck on last time. See if I can make any more progress with it. Okay. Now here we've got to expand this again. Okay. Okay, okay. Okay, we got y equals 3 minus x squared and x plus y is greater than 1. We can substitute that in again. I guess what that means also is we don't technically need to take this one off the other end, right? I'm going to do it this time anyway, just to keep things simple. So let's take one. You do need to. Okay. All right. Minus x squared. Okay. Right, and then we do this bit, but there's a negative on here. So that means one of the x's will have to be negative. And this will have to be a positive and a negative. But we don't know exactly which way round they're going to be. If you didn't, you need to find where that function crosses y equals 1. Yeah, that's what I was wondering. I was wondering if that was also an option. Obviously, probably a less good option, but... Okay, let's just put this here. Come on. It's starting to cool. Laptop's starting to get hot again. Whoa! Okay, that's enough. That's enough of that. Okay. And we're probably going to have a 1 and a 2 here. We could try this, then we get minus x squared plus 2x minus, oh no, we get plus x, and that's not what we want. That's not going to work. So, other way around. or we could flip the negative around. Then we get no, we get minus x minus 2x. No, that's not right either. So can we do this? If we do this, then we get plus 2x minus 1x, that's just x, minus 2. I think that's what we want. Yeah, and then we get minus x squared plus x minus 2. And is that what we had here? I think so. Happy Norris says, oh, we could multiply by minus 1 and flip the... Oh yeah, that's true actually. That's a good point. That would have made it a bit easier. Okay, good trick. By the way, in a standard form... Oh, that's what you meant by A earlier, of course. Yeah, because of course we've got this whole thing. Of course, this is how you work out what to plug into the quadratic formula, right? Right, okay. Standard form, this. If this is negative, the parabola is looking down. As in, like this. And if it's positive, it's looking up. We might be imagining different ways of looking. Anyway, okay, well that's useful to know. So it's negative. Oh, opposite. Okay. So, oh, right. You mean it's like in terms of a smile. I see. Okay. Because it's got, you know. Right. So this is positive because of course it's smiley. And then this is negative because of course it's frowny. Right. So that's what A does. Okay, cool. Alright, so this tells us that this is going to look like that. Cool. Thank you, Nima. That's a nice tip. Alright. So, okay, so we got this. Now we've got that. We know that the intersections, I guess, is what we're getting there. The intersections are going to be minus 2 and plus 1. So we're going to end up with these are the intersections at x, I suppose. So the intersections are going to be here, I guess, I assume. Actually, let me change the color for that. You know, I really think this sound is actually helping. Hope it's helping everyone else. Okay, alright. So... it's gonna end up looking then something like this. And I guess if it's x plus y... No, wait, it's... Or is that the intersection with the other thing? Okay, well, before we graph that, let's try the thing we did previously. And try plugging the thing in and seeing if we can work out what the thing should be. Okay, so, and then we can graph it and see, just take a look at that. So let's say x is in the middle. And we've got, sorry, we've got -2 multiplied by 1, which is going to be -2. Lana, hello. Multiplication was done wrong. Still? Thank you for pointing that out. Still wrong? Attention to detail. Using the quadratic formula, it has no real roots. Oh, good. Okay, good. Okay. Right, let me figure this out again. Okay. Right, so I got this wrong. So this is -x squared, fine. -2 minus x will be +2 x. Minus x times, sorry, x times +1 will be, of course, plus, yeah, okay. Yeah, I did get that wrong, didn't I? So, Lana's saying the quadratic formula tells us we've got no good, we've got nothing good happening, I think. So let's see, just for fun, let's see if I can remember the quadratic formula. Now, I think it is -b plus or minus b squared minus 4ac over 2a. So, a in this case is -1. B is 1. C is -2. Unless I've gotten some aspect of this wrong. Of course, it could be Claude has given me like a completely impossible question, which would be kind of funny. Okay. I guess this is x equals. So we have -1 plus or minus, and we've got 1 squared, which is 1 minus 4 by -1 by -2. It's not impossible. No real x or all x are valid answers. Oh, interesting. I guess that's true. And then 2a, that's -2. This is a 1, don't forget that. Okay. Now we've got -1. No, wait. Let me just copy this out. So -2 by -1 is just going to be 2. Four by 2 is 8. 1 minus 8 is -7. I guess that's where the non-real thing comes from. And then we run out of my maths. We run out. Or can you do this in this context? Square root of -7? That's not allowed, right? I seem to remember. This doesn't let us do it, or anything. Okay. Well, that's as far as we get with that. No roots. Just means the whole curve is below the x-axis. Okay, let's take a look at this. Right. 3 minus x squared x plus y, for which values of x does x plus y is greater than 1 hold? Right. So x plus y is greater than 1 is this shaded area here. Oops. This shaded area here. Okay. Let's go. This shaded area here. I mean, I know I must be wrong, but it just seems like there should be an answer to this, right? The red graph here doesn't make much sense, at least to me, because then you have two functions. I guess I assumed they would be related graphically. Maybe they're just not related graphically at all. I mean, let's plug in the other one that we made. The other one we made was minus x squared plus x minus 2. Yeah, doesn't it? It's nowhere. Or, yeah, I don't see it anywhere. I guess I could do this. I could do this. Below the x-axis, indeed. So there's no... Well, there's no solution to this. We kind of know that, I guess, from what we've just done. Right. Okay, given the curve, for which values of x does this hold? So if we're thinking about this curve here, what values of x have we got? So we've got all these. All these here. we've got, for example here, we've got 0.4 and 2.84. If we added them together, they would be above 1. Right? Am I being crazy? Please replace y in the first equation with, say, g, and in the second two, y is a keyword in Desmos, I think. And in the second one too. Oh! Wait, no, is that right? Okay. 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 Is the graph confusing me? Maybe. Neo, help me. I just did 95 kilograms at 7 reps. Can you calculate 1 rep max with that formula? The 1 rep max formula. Okay, what is that again? Okay, the 1 rep max formula is... It's W by 1 plus R over 30. Come on. Come on. Oh yeah, I'm in the wrong color. Okay, it is W by 1 plus... This formula is really silly, by the way. Okay, alright. We need to have some important side business to conduct. It's not allowed. It's not allowed. Okay. Alright, alright. Okay. Wow, what a bizarre thing. Okay, okay. I don't think this is gonna get... Not sure this is gonna get the right answer. Wait, probably would be less confusing if I didn't swap around the things. Okay. Right, so x is... Let's say x is 75. 95. Okay. Okay, there you go. Your 1 rep max is... No, wait, it's reps. Sorry. Reps. Which one's reps? R... No, wait, I made it up. I made it up. Okay, here we go. Okay. Okay. 7. Okay, and x is the weight. Okay. Alright, 95. No, it's the opposite way around. Okay, we must be the other way around. Must be the other way around. Wait, what on earth is... What is happening? What's happening? Okay, here we go. 95. Okay, it's 117. There you go. 117. What was the movement you did there? Really depends on that. Okay. Alright, where were we? I did algebra wrong on the 3rd line. On the 4th line. One of the lines. Okay, wait. It would track if I did that wrong. Okay. So, I'm doing this. I'm doing this. I have done algebra wrong. I've done it totally wrong. What am I doing? Oh my gosh. Why did I ever think I could do anything? Alright, let me see this again. Just make sure there's no mistakes on this part. Let me just do the whole thing. No, let me not do the whole thing again. I'll make the same mistake again. Let me do this. Okay. Alright. Substituting in. We have x plus bracket 3 minus x squared greater than 1. Oh no. New mistakes. Coding bar though, what was the movement? What did you do 95 kilograms of? Okay, right. I'm gonna say that part is right. Okay, now we don't need these brackets at all. The brackets don't make any difference, so that's fine. Then we subtract 1 on this extremely messy board. We subtract 1. No funny business here, okay? Just do it the hard way and don't get it wrong again. Okay. No. Okay, now 3 minus 1 famously is 2. Not minus 2. So x plus 2. I was about to do it again there. This. Okay, now we rearrange. You know that meme of the guy just like sweating with concentration? I really feel like that right now. Minus, 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 plus, plus. Okay, all right. Okay, now we've done the first basic steps correctly. Oh my gosh. Well, I learned a lot along the way. Let's get a temperature update. Oh, okay, good. It's gone down. The temperature is coming down, everyone. Right. Okay. Okay. Now, let's try this again. Okay, coding bar, I'm going to guess. Was it... Was it overhead press? I'm being very charitable. If it was overhead press, then oh my god. Right. Now, before we go any further, let's just take a second here. 2A, so we've got A, and that's gonna work. Now if we have B squared minus 4ac. For that we've got 1 minus 4 by minus 1 by c, which is 2. This will be minus 2. And this will therefore be minus 4 by minus 2, right? So that will be 8 plus 8. No. No. 9. Famously 9. 9 has a root. Okay, alright. Okay. Okay. So, let's try this again. I may as well have just done it with the formula there. Right, so we want, I think, no, it's a plus, so they'll both need to be pluses. Or they both need to be minuses. But let's try pluses first. Now in this case, that actually can't work. No, actually it can work. If we have 1 here and 2 here, maybe? In which case we've got minus x squared plus 2x minus x plus 2, which gives us plus 1x. And that's what we want. Okay. Fine, good. Right, so in that case, we've got intercepts, I guess, of plus 1 and plus 2, if that's even the right word. Intersects, maybe? No? Okay, that's wrong. Let me plug in some stuff and just figure out a little bit more about this. If x equals 0, we've got 2 by 1, so we've got 2. 2 is greater than 0. So two is in the kind of zone. One of the roots is incorrect. Again, oh my gosh, okay. Does this minus x affect anything? Maybe. Let's look at the graph. Minus 1 and 2. So the minus 1 for reasons to do with this x, maybe? To do with this, to do with this thing here. Oh, you mean this thing is wrong. I see. P-Signal is saying this. Minus should be outside. So we're not allowed to do that then. I see. Hello, Stian. How you doing? You having a good day? How was your stream? So the way we get to this then will be to do this. Happy Nora said the right thing earlier, really. And then we can flip this. Which makes it easier to deal with. What do you mean that emoji's lame? I use that emoji all the time. That's my favorite. That's my favorite one. Oh, welcome. Here it is. You're seeing it right now. You said, yeah, you said multiply by -1. That was a good idea you had. Gosh, this is painful, isn't it? Really painful. Yeah, it looks a little like do it with the formula. Do it with the formula. Okay, fair enough. I always thought the formula at school they taught me the formula was giving up. The formula should only be used as a last resort, like it was lazy or something. Yeah. Okay. The formula. Well, I guess the formula you don't need to do all this nonsense, do you? I'm here now, I suppose. Okay, so minus and plus must be that. Must be a +2 and a -1. X squared plus 2x minus x minus 2. Is that what we have up here? Yes. Yes. No. No? Are you saying no to me? Other way round? Oh my gosh. I'm gonna lose it. I'm gonna lose it right now. I'm gonna lose it. I'm gonna crash out as the young people say. Surely not the other way around. Oh, because it's negative now. Because it's negative now. Wow, this is actually horrendous. Really dire. Okay. minus 2. Because of this. Because of this. That I forgot because it wasn't there last time. No. Yeah. Yeah. Alright. 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 Okay. Okay. So. Hope you're enjoying the stream. Multiplying by -1 doesn't change the roots. I guess not. I guess that does make sense. Yeah, so -2. So we're going to be in the middle. So it's going to be... If it's in the middle, it can't be like the middle and the outside, right? Are you joking? The roots are 2 and -1. I think you lost the point what we're doing. Okay, great, okay. Okay, great. Okay. I lost the point what we're doing. You're probably right. Does this sign mean anything then? We're searching for the roots, so yeah, so that's true. That is a good point. So for this, right, so for this, it's not just take these numbers, obviously. I should know that. I think the inequalities, obviously, it just seems not true, basically, to my brain. I just don't think this makes any sense to do it with that, but obviously it does, because it works. So for this to be 0, this will have to be 2, and for this to be 0, this will have to be -1, right? Yeah. 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 You know maths. Yeah, don't let me confuse you, Stian. It, if you're not getting the right... If you're getting a different answer to me, you're probably on the right track. Okay. Now, we know... What's still true is we know that this is still in the thing. We know this is still here. Because, at least I think we do. Which means... Well, there's only one way for this to be valid, which is this. I'm sending it. I'm sending it. I'm sending it. Oh, look, it's already there. Okay, great. Thank you. I'll just tab through that. Yeah, there you go. No worry. Great. Thank you, everyone. That was really horrible. Oh no. Oh no, more okay, great. Alright. I think that's what are you doing solving my problem for me? Okay, that's enough AI driven algebra practice. I did learn something from this. This was a worthwhile exercise. Okay, so here's what's going to happen now. What did I learn? We got a teacher here, do we? We got a wise guy. What did I learn? I learned that I learned that I have a less good understanding of what these problems are about. Which is useful metacognitive knowledge. I learned that I relearned, although I forgot, that we're about, when you're trying to find the roots of those things, you're looking for the cases that it will end up being zero, which I did before and just forgot, but it also applies in inequalities. I learned graphing is useful. I learned recently, you know, the multiplying, dividing by -1 thing. Not today, but as a part of trying to do this better. I probably learned some other things. Whoa. Stian, you can't even reply to that. That's brutal. You can't even reply on stream. You can't even load up Nano. Nano? Nano. Oh, he's banned. Okay, he's banned. Name. The number of streamers you can visit is dwindling. Okay, so here's what's going to happen now. Now, those of you who've been here a while will remember the space. Thank you. The space image that I put on when I'm taking a short break. Now, because Stian will appreciate this. I've got a whole new setup. In fact, let me show you something. Let me show you something. Let me show you what's going on here. Let me show you something. All right, now you're about to see behind the curtain. So no, but don't tell anyone you were here. Nobody raid me for nobody raids me anyway, but nobody raid me for the next 2 seconds. Now look at this. Okay, so firstly, we're gonna undress the camera. Okay, so we got that. And then we got this, right? So you think, okay, Kay's behind an incredibly bright pink screen, right? No, it goes even deeper than that. Now this may break the whole stream, so okay, all right. And then you think it's probably some kind of black screen, right? No, it's a blue screen. Now this is all new. It doesn't work very well. I was speaking to some friends at the local pub recently. Now this is going to screw everything up. It's going to ruin everything. And there we go. And they felt, I was like, you know, I've got a new blue screen, I've got a new green screen. And they're like, oh, can I come over and like play around with it? I was like, you don't know what this is like. You don't know what this is like. None of this works. You have to like do all kinds of horrible things to make any of this work at all. You got to have lighting, and I don't, you know, it's not a room in which you can have lighting, frankly, especially today. So, yeah, but so why the pink, you wonder, right? Well, turns out that transparency, we're dealing in a horrible universe where transparency won't flow through certain channels. Certain wires cannot contain opacity properly, including the ones that come from my device that records me and is doing the keying through hardware right now, and my laptop. As a result, I key once to get the pink out, to get the blue out, and then I key again to get the pink out. The hardware keying is slightly better, but the pink, see, here's the thing, right? If you this is really tedious. Oh, I should really stop talking about this. But if you have hair Basically, if you want to do any sort of blue screen, key screen, my advice to you is be a bold man, because keying hair doesn't make any sense. Doesn't work at all. So like you can make it work, but it's like quite, you know, you need really good conditions to make that work. Anyway, so you're gonna have some stuff around the hair. Anyway, I kind of like it if what's around the hair is a nice color. So there we go. Who takes out the rest of the leftover parts in the corner? Well, that's an image that I made. Yeah, I like to think of it like I'm a hologram. Anyway, so there's all kinds of new stuff. One new thing which is going to happen right now is I have a new pause screen, which I think looks pretty exciting. I think you're going to enjoy it. So I'm going to take a short break. And, whoa, what was that? And you're going to see the new pause screen, which I think you're gonna enjoy. So see you in like 2 or 3. Enjoy it. You may have done, Stian. Okay, so we're returning. We're returning to the problem that defeated me last time, and we're going to be possibly, well, if today is anything to go by, we're going to be defeated by it again. I play World of Warcraft. No, I don't. I would never do that. Do you? Okay, wait, let me get a temperature check. Let me see. Let's refresh. 31, okay. Okay. Still good. It could have been me. It could have been me, Stian. I could have just been laughing. Laughing to myself in the other room. No, I don't know. I mean, this is from the Netherlands. The Netherlands is one of those places that I do not know where it is. They launched the V2, the first V2 rocket from the Netherlands to London, I believe. Oh yeah, there it is. North of Belgium, west of Germany. Yeah, they launched the first V2 rocket from the Netherlands to London. Fun fact. Well, not fun fact, actually. If you're not joking, Stian. You're worried about this orc. Is that right? I'm sorry. It could have been the audio. Could have been the sound. The Netherlands could contain an orc of some kind. But yeah, I don't know. I wasn't listening at the time. But it could be. It could have been an orc. The sound is supposed to be cooling. It's from snow. There's supposed to be snow in it. Okay, so right. So the question. Hello, Deep Web Impact. How you doing? How's your day? How's the temperature where you are? All right. Can I draw a real thing? Kinda. That'll do. If X is in the reals, and it's between 0 and 4, exclusive, I guess, then we've got this. Okay. Or over x4 minus x. Yeah, it's warm. What's the temperature where you are, Deep Web? Storm noises may feel even cooler. That is possible. It's possible. There were some of like ice flows and stuff, but I thought it wasn't evocative enough. Anyway, so I was going to say this by this thing. I do feel that I was thinking, isn't that sick? And then I thought about what I said in your stream earlier, Stian. I'm sorry I insulted your user interface as well. I made a faux pas earlier, everyone. 23 degrees, partly cloudy. That can still be warm, right? Yeah, I accidentally said that Stian's user interface looked dick as hell, or something like that. It was a hilarious moment. It's the kind of humor. It's the kind of humor you get. Okay, so if x is in the real numbers and it's this, then that. Right, there's no y's in here or anything, which immediately slightly stumps me. I guess, yeah, we were going to graph. We graphed this last time. Yeah, we're trying to prove that within that interval, that thing is always greater than or equal to 1. Oh, I don't feel any closer to knowing what to do. Oh, so annoying. Still, I have some additional tools. Yeah, name is permaband. Okay, let's just do something with this. Let's do something with it and see what we get. So we could put it another way. We've got minus x squared. We've got this. Now I think if you... Hello, Decker. I was getting an AI, a captive AI, from behind the black wall, beyond the black wall, to generate algebra questions for me to try and improve my skills, and it gave me something to think about for sure. Yeah, more info about X. I guess we've got this. We got this. Sorry, what am I doing? What am I doing? So I'm feeling like if this, for example, if this was like this, I would have no problem just substituting that in, right? But it's not. It's not like that. It's like this. And I don't know how to substitute that in. Am I allowed to multiply both sides by... Yeah, I guess so. I guess so. As long as that's not negative, I suppose. It's on my list to read Dolciani Algebra. Have you heard of this book? No. What is it? What is it? What is it about? If that's not too silly a question. If we could end up with like If we could transform this into this form, and then it ended up being like, or I guess it would just be this. Yeah, if we could do this, and we could have this end up as, I mean, maybe that. Maybe we'd have something there. If we could do that. Amy's asking me a question. Since I guess you mean that? Do you agree that that is going to be greater than 0 always? Well, I guess we can plug it in. Now, if that's going to be, let's say x was 4. Hello, Mean Machine Rex. How you doing? Okay, 4 minus x. Sorry, 4 minus 4. This would be 0, which would be 0. If it was 1, we would have... No, wait. No, it would... No, wait, I did that okay. I did that a little bit wrong, but I think I did it okay. 1... 4... No, sorry, it should be 0. 0, 0, 0, 0. Okay. And then it kind of... We've got... I remember us having this thing in the middle, right? We had like 2, and then 4 minus 2 is... Well, 2 by 2 is 4, famously. Yeah. It's so hot, Mean Machine. It is warm. What temperature is it where you are? Okay, so let's say it looks simple enough. It's going to be positive. So, let's say we can do that. In which case... we get to do this. (35°C). You must be on the continent, maybe. So you must be France or something. Well, you don't have to say, obviously. You don't want to. Yeah, they're saying France is very warm. And they're saying it's got tiger mosquitoes. Okay, so we have that. That looks kind of nicer. Oh, well, I guess we can then... Well, I suppose we want a 0 on the left, maybe. I guess we still need that. So we're subtracting 4. And then we've got to refactorize that. They're breeding mosquitoes with tigers now, Zam. Yeah, they are. Apparently they suck a lot to be bitten by. And if you're in the UK, there's a special task force that will come out and deal with them for you. Okay. Minus x. Yeah, we got to this before, and I know a little bit more about this now. Minus x squared plus 4x minus 4. Any errors there? Any errors there? X by x. X by minus x is minus x squared. X by 4 is plus 4x, and then we got this on the end. That's a perfect square. This is what we do completing the square, right? Is that what I've... Or is that not? It's not. Is that not it? Anyway. So Then let's get rid of this minus. -4 plus 4, which we then want to by -1, in which case we have this. And then we factorize it again. Oh, it's going to be the same on both sides is what you're saying, Nemo. Oh, interesting. So it's going to be, yeah. Yeah, what's that going to be squared? Could be 2, 2. Can't be 4, 1, I don't think. Okay. So we get that. Great. Now, what does this mean for anything? What does x have to be for that to be 0? It's got to be 2, right? That doesn't seem very helpful. You win the bet, Happy Nora. Something squared is always positive. So you have proved it. Oh yeah, that's what we're supposed to be doing, right? If x is in the reals and x is between 0 and 4, which is what we've been working out, then that formula is greater than or equal to 1. Okay, so we've done something with this that feels like what we're supposed to do, but I still need to understand in what way this proves. Oh, I've got a blue dot on me. In what sense this proves anything? So, what have we actually done here? We've said that within that range, x minus 2 squared is always going to be above 0. So no matter what x is, so x minus 2 could be, okay, so let's say we're talking about this range, right? 0 to 4. So minus 2 squared, we're going to get 4. 4 minus 2, we're going to get 2 squared, which is 4. 2 minus 2, we're going to get 0, so we're going to get 0 there. See you, Stian. Thanks for hanging out. Hope you have a good rest of your day. Thanks for the follow too. Okay. Right, so it's like, it's a kind of if-then type logic. So what we're doing here is we're saying if, yeah, the question is if this is true, this and this, then this is true, prove that. The way we prove it is by taking this. So all we've done here is we've taken this and we've rearranged it into this form. So great. We've rearranged it into this form. We haven't actually used any of this information yet. So we can't possibly have proven the if-then purely on that basis. And then we were saying it will always, this is always going to be positive. So this, we know this is going to be true. We know this is going to be true. Do we know this is going to be true whatever? Is that what we've found out? Because we haven't actually used any of this information, I don't think. So we know this is true for all x's. Abhinora says, oh right, it only holds, yeah, okay. So we did, yeah, we did make an assumption indeed that this, yeah, we did use it actually. Yeah, we did. You're right. We did use it on the step where we were allowed to do this multiplication. Okay. Did we prove that step? We kind of wanted to prove that for that to be the case, we wanted to prove that this is greater than or equal to 0. So we did use that information. We proved it, I proved it very loosely just by looking at some numbers, but you probably could prove it within this range, couldn't you? Yeah, maybe it is obvious. It is obvious from just playing around with it, that's true. I don't know, yeah. Don't know if that's sufficient. But we didn't use the 4. So we've just proved it for everything above 0, right? Which is fine. It includes above 0. So that's alright. Oh, true, actually. Although, we're not dividing by 0 here, are we? I guess we kind of are here. So if this was ever 0, then we'd end up this not being greater than or equal to 1. So can it ever be 0? Well, it can be 0 pretty often. Oh no, because it's these boundaries don't include that, do they? Yeah, so it can't be 0. Right, so that's where we use the for. Because it's not allowed to be 0. Because if it was 4, then we'd have it be 0. So I guess that's where we use that information. I guess that's true. Yeah. I think that's a good exercise, Nimar. I will do that now. So because it's a quadratic, we get to assume that it has a certain shape, I suppose, that it's not going to cross it like multiple weird times. Sorry. So in which case x either has to be... So the roots of this are going to be 0 or 4. Yeah. Okay. And then yeah. Okay, and we could like plug in like 2 and find out that it was fine. Okay. So because we've proven that we've could we even have just stopped here? I don't actually know if we could have even stopped here. Probably if we had a very rhetorical point of putting it, maybe. Nimir says no. Okay. I'm going to look at these on the board as well, on the graph. Where even were we? Okay, 1 second. Now, this may not make sense to graph, actually. Well, let's... So we're in that zone. And then I guess let's just put it on, see what the software does. Oops. Okay, it does the same thing. All right, well that kind of, I guess that would kind of make sense. Yeah, okay, I remember this. Yeah. So if x is between but not including 0 and 4, then that formula we've put in is going to be greater than or equal to 1. That's what we're kind of saying here. And indeed we can see that there's a 1 minimum. Okay. I had to arrive at true for the main inequality. With only that you've proven for... Okay, fine. Right. So I had to work out that it was actually true in the actual... Okay. All right. Okay, well, there we go. Thanks, everyone. As always. By the way, we need, we need the, we need this, we need the double. The if, that's the if and only if, right? Double. Not this one. Which is implies, right? It's like... Yeah, this one here is the true, false, true, true one. Hello, e to the 2i pi, sorry. How are the inequalities today? Well, they're treating me pretty badly. But I'm learning to deal with them. And then this one. For this one, what's the truth table for that? Right, it means they have like... Okay. Let me get my head straight on this. Even my handwriting is melting. Whoa, okay, come on. That's enough lag. One is true, the second one must be true too. And if one is false, the second one must be false too, right? That's what this truth table is indicating for us. Yeah, P implies Q and Q implies P. Okay, so they're equivalent. Kind of. Like you can't have one be true and one be false. I guess that does make sense. Okay. And so, right, okay. Okay. Right. What next then? How are you, e to the 2i pi? How have your streams been going? All right, we'll get Richard's view on this as well. Gonna have some milkshake. Okay, suppose x and y in the real numbers. If x squared plus 5y is equal to y squared plus 5x, then x equals y, or x plus y equals 5. Okay. They're in the big R. Whoa, terrible big R. I need to do that again. Yeah, there we go. If x squared plus 5 y is equal to y squared plus 5x then either x equals y or x plus y equals 5. So we've got some logic going on here. Sorry for any drinking noises that you may be exposed to in the course of this stream. That wasn't what I wanted to do. There we go. Right, so one of them, if it was just like one, if there was no or here, right, we could just substitute in x or y and maybe we'd get something that proved it. But we can't do that. So we need to do something else. Do one by one with substitution. Seems like a decent... I don't have any better ideas. Okay. Well, that wasn't so difficult. Well, that's going to be true always. Guess I'll just do the other one. Oh yeah, we're talking about, yeah, or... Yeah, what was that one again? It's not, it's, oh my gosh. Wow. Can't believe I forgot that. If it's inclusive or... Well, it doesn't matter. I'll just do the other one, see what I find out. If they're both true, then great. Right. So... What is that? What did I do there? Is that supposed to be a 5? Oh my gosh. Terrible. Okay. So then let's expand these, maybe? Or maybe we don't need... Let's just look at it for a second. I don't see anything massively obvious we could do with either of... with this. Yeah, I don't see anything obvious. Okay. So, okay. Let's expand this. Y squared, because it's minus y, minus 10y plus... Don't open it. They miss saying don't open it. Well, I can not open it. If I don't open it, what do I get? You mean keep opening it, Namer? You mean... Should I keep going? Just keep going? Just do what Namer says. Oh yeah, okay, 25. 5 by 5 is 25. 5 by minus y is minus 5y. And then I guess we just collect a bunch of stuff on one side. Let's... Or can we divide anything? Nothing really obvious. Yeah. Let's go minus 10. Which would give us 15 here. And get rid of this. Then we can add 5y. Oh, sorry, take away 5. No, wait, I haven't even... Haven't even collected these things together. What am I doing? So actually, let's keep that, and then let's say we're going to have minus 5y here. Get rid of this. Yeah, then we can add 5y, which gets us y squared equals y squared. Oh, not looking good. This is never true, right? Even if this was some sort of crazy negative thing. No, it wouldn't make any sense. It wouldn't make any sense. So that's never true, right? Yeah, unless I've made some sort of mistake. Let me run that through again. So we were substituting that in. We substitute in the... yeah, the 5 minus y there, not here and here. We expand that. We have y by minus y is y squared. Minus y by 5 twice. That's minus 10. Then we've got 5 by 5 is not 10. That's 25. Okay. Can I do anything without making elementary mistakes? Okay. 5 by 5 is 25. 5 by minus y is 5. Okay, great. So now we can get this right. We can take away 25. Hello, coding barra. Again. Okay, so yeah. We get rid of this. We get rid of this. We've got a minus 5 here. And we've got the same. So they're the same. Happy Nora's done something else. Yeah, Happy Nora collected. So you've all gone some other way by finding Finding some roots? Is that what that is? Is that what you're doing? So what I've done here, though, what I've done here seems to show that these things are true in every case. Let's see what Richard says. See what Richard's up to. Suppose that then x squared minus y squared is equal to 5x minus 5y, and factoring gives us that. Now consider two cases. If x minus y is not equal to 0, then we can divide both sides of this thing by the non-zero quantity x minus y to get x plus y equals 5. If x minus y is equal to 0, then x equals y by adding y to both sides. Thus x equals y, or x plus y equals 5. I'm not satisfied. So here's how it seems to me. We've got this thing. We've got this thing here. Suppose this is true. If this thing evaluates, if this thing is true, if this side and this side are the same value, oops, then either this is true or this is true. So my action, which does seem like it can't be right, otherwise it would have been the obvious solution, was to substitute in this into this. And then they're kind of obviously the same. And then likewise here, you kind of take them out and then it's obviously the same. Let's do 728 says add and subtract -5 over 2 squared on both sides. And that leads to x equals y. Alright, fine. I'll take that. I don't quite get... I mean, we can factor it, right? That's fine. This whole thing works. This seems... The approach I've taken here seems too simple to not be the given answer, I guess. I guess that's what's confusing me. Maybe it doesn't matter. Maybe it doesn't matter if that's right. Weird though. Okay. Let's do some more. Always do more problems. This one's telling us by cases. Now, I didn't even... no, actually I did read the by cases bit, I think. I did read it in the end. Okay. Right, 14. How many more streams do you think before I get through all of these exercises for chapter 4? 100 maybe? Okay, come on. Alright. Okay, we've got that. Fine. Oh, we're back in the world of the integers. What a delight. Okay, we got 5 n squared plus 3n. I do think my handwriting is getting a little better. A little. Just a little better. Right, let's try and do this properly. Suppose... What are we supposing? Are we just supposing that thing's in the integers? And then how does he write it in the whole thing? He's got some whole scheme for how he writes it. Yeah, and then he's like we need to show that and he kind of puts it like this, and then he's got case 1. Right, so we suppose then, do we suppose, maybe we could suppose that it's, suppose n is, I guess there's only 2 cases natural to do here, so it's got to be odd. Now, I guess the thing that cases lets us do is if we then have case 1 evaluate to true, and case 2 evaluate to false, then it must be odd. Whereas if we only prove one case, we only show that it can be odd. Wow, I just blipped out for a moment there. Got like Thanos snapped out of reality. How many years has it been? So, wow, really, everything's broken. Am I still here? Crazy. Okay, let me just check. Just check everything is working. Okay. I'm still here. I'm still alive. What is happening? Okay, we're back. We're back. We're back. Okay. Right, everything's slightly wrong, but... Okay, fine. Okay, let's just assume I just got Thanos snapped out of existence for a second there. Just like for 1 microsecond. Okay, suppose n is odd. Now, in that case, we got that formula. So we've got that, and then we've got this thing, don't we? We've got n equals, let's say, a. It's 2a, right? 2a plus 1. Now, if we had that, then we'd be able to say, we'd be able to substitute it in. Let's see what happens there. We've got 5 2a plus, yeah, what are we trying to do? We're trying to put this in the form of like an odd number or something like that. Maybe something like that? I don't know. We'll see where it goes. And then let's expand. No, we can't take a 2 out of that yet. Wow, it's been like 1 stream since I've had to do this. Okay, so we get 5 by 2 is 10. 10a plus 5. No, wait. We're squaring it. So we have 4. Yeah. So we're going to have 4a squared plus 4a plus 1 plus 3. Oh, we need to substitute that in 2. I forgot to do that. Well, we might not even need to do this substitution at all. I'm probably just on autopilot. We could just try and put this in a form, maybe. We might not be able to do that. I guess let's just keep going and see if it takes us anywhere interesting. Okay, let's just cut our losses and say that we're gonna just take this as a checkpoint. Okay, let's keep expanding. Now for this we've got 6a plus 3 plus 7, and then we've got, let's put that in, and then for this we've got 20 a squared plus 4a plus 1. Oh, come on. Focus, 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 focus. 20 a plus 5. Yeah, and then we get all of this in here too. Right, now let's collect all this up. We've got 20 a squared plus 26a plus 5, 3, and 7. That's 8 and 7. And that's 15. Ugh. Oh no, wait, that kind of works actually. Money makes the world go round. Great username. Damn, this looks extremely hard. It is. It's challenging for me, though. If you'd like to hang out with a bunch of people for whom it's not challenging very much, then my chat is a great place to be. Okay, so welcome, by the way. How are you doing? Is it warm where you are? So if we have this, we can extract a 2 from part of it. We've got 13a plus, and we have this, let's swap this to be 14 plus 1. We've got 7 plus 1, which means therefore what? I don't know if this actually helps me at all. I did some work though. Okay, 14. No, wait, we're not saying anything about n being odd. I don't know why I even did any of that. Well, I guess we've shown for some reason, totally irrelevant reason, that if n is odd, then the result will be odd. Great. Not helpful, but good practice anyway. Okay, so what are we actually trying to do here? It is warm, but this math makes it even warmer. Yeah, I know how you feel. Okay, well, I think that was pretty much pointless. Yeah. Still. Okay, let's try this. So that was a bad choice. Oops. Collision detection a little bit off, I think. Okay. So we don't want to suppose n is odd at all, actually. Okay, back to the drawing board now. Right, now what was this form? What was the way he said this again? We need to show that 5n, let's say equation 1, whatever, is odd done in 2 cases. So we could say that what could we do? Okay, so we could try making it equal to the... We could do something like this, maybe. Yes, not doing that. Could do this, maybe? Let's see where it goes. Alright, let's do a bit more writing. That's an interesting idea, Happy Nora. I guess I have shown that if n... Right, so this cases thing is like a way of breaking down the problem. I've shown it for if n is odd. And now I need to show it for if n is even, I guess. And if I did that, it would add up to the... It would add up to a proof. In general. Seems kind of funny, but I guess it does make sense. Right. Okay. Well, it's a shame I deleted all that stuff, but there you go. Let's assume I got it. Money makes the world go round. Why are you learning algebra for AI? Will you build an AI yourself? So I'm actually not learning algebra for AI. I was learning algebra earlier in the stream. I was learning algebra with AI. It was generating me some problems to do. So it was just Claude. Claude was generating me some algebra problems because I'm trying to learn about proofs, so that I can understand Donald Knuth's genius in more depth. And I was coming up against my algebra not really being good enough. So I did a bit of algebra drilling. to improve that, and made some progress in doing so. Okay, so let's substitute that in. Five 2a squared plus 3 2a plus 7. Then we've got 5 by 4 a plus, let's say, 6a plus 7. And then we've got 20a plus, no wait, a squared. 20a squared plus a 6a plus 7. And then hi Maloran, yeah, back at it with more proofs. Is it just me, or does this not work at all? We need to be able... Oh no, it's got to be odd. Sorry, I keep forgetting. So in that case, we can extract the 2, get the 10a squared out, 3a plus 3 plus 1. Oh, I probably need to have a different letter for that. What does he say at the end? He says... These cases show that, yeah. Just to prove it in my head. How are you doing, Maloran? Is it warm where you are? No matter the case. Nice vocabulary. All right. Look at this. Madness. The real madness is why I intuitively hold a mug like this, even though it's clearly supposed to be held by the handle. Gotta get this one in. Malone, you have AC. You have air conditioning. Wow. What's that like? Are you in a country where air conditioning is common, or are you just very special? Okay. 14. Temperature check. 30. It's coming down. It's coming down, everyone. You're Swedish, so AC is very much not common. But a few summers back we hit 30 plus C for a few weeks, so I bought one. Easily the best purchase I've made in years. Ah. Yeah, they're saying it's a good idea. I feel like a lot of people in the UK suddenly this year have decided that it's like really worth considering. Somebody told me it adds 15% to the value of your house recently, which is kind of crazy. Okay, 15. Come on. If n is in the integers, then n squared plus 3n plus 4 is even. Okay. I'm going to try and do it properly again. Oof, come on. N squared plus 3n plus 4. It legit made me go from hating to loving summers, since now I can actually sleep at night. Yeah, I can really imagine that. This is not the right way to write it. How would they write it properly? I don't know what's important yet. We need to prove that I don't know what the right grammar is. The case in which n is odd, then the case in which n is even, Lauren says, style in mathematical writing is very much a practice skill, and different authors will have different styles and proofs, and eventually you'll even develop your own style and preferences. That will be exciting. Okay, so n is odd. So we've got Let's do that. Okay, so we're going to have 2a plus 1 squared plus 3 2a plus 1 plus 4. This thing gives us 4a squared plus 4a plus 1 plus 6a plus 3 plus 4 The universal style is a proof left as the exercise to the reader. Yeah, one day I'll get there. One day I'll say that. Okay, then we collect some stuff. So we've got 4a squared plus 10a. One piece of style I should pick up is not having small zeros. Okay, plus 8. Even my mental arithmetic is getting better. The hard stuff is easy and the easy stuff is hard. Okay, now we can extract the 2. I don't know if anyone noticed, but I made the little grid lines a bit brighter, and I think I am following them better now. Lauren says, I actually changed my handwriting quite a lot when I went through my maths studies. Oh, interesting. My handwriting and spelling were always bad from an early age. But then when I got old enough and experienced enough to use computers, I started being able to use spell checkers, and spell checkers gave me like immediate feedback on my spelling to show me when I was spelling things wrong, and then my spelling got like basically great overnight just because of that, which was a real education in how tools can be very useful for education. They can't merely steal the learning from you, but they can help you learn as well. Maybe this will be that for handwriting. Obviously nothing ever helped for handwriting, but my handwriting and sketching has always been a bit of a weakness, and if you're an educator like I am, it's nice to be able to communicate clearly with a variety of means. I feel like it's getting a bit better. Okay. Okay, so that's the case in which n is odd. Let's look at the case where n is even. Okay, let's do that. Now that's going to be 2c squared plus 3, 2, 2c plus 4. We then get out of that 4c squared plus 6c plus 4. And then we should be able to extract a 2 from this. 2c squared plus 3c plus 2. What was the happy Nora you said earlier? It was no matter the case. Now we get to put it into practice. Yeah. Wow, that one went kind of smooth. I think that's the smoothest one yet. Alright, let's see what Richard's up to. Thank you, Desiree. Whoa, okay. Yeah, that one went okay. Right, 15. Oh yeah, I missed that part. We consider 2 cases. Alright, so that's how we phrase that. Da 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 da. Yeah, cool. Oh yeah, so this is the even one. And this is the odd one. In either case. Cool. Okay. Neat. I'm happy to tell you that we have dropped 405 frames over the course of this stream so far. Did anyone notice them? Did anyone notice the frames that we dropped? I think I saw one. They're all over the floor. Okay. 16. If 2 integers have the same parity, then their sum is even. Well, this seems like an exciting one. So that's the case in which let's say like odd plus odd and even plus even. Don't know what that is. Lauren says, are you using a tablet or mouse to write? I am using a tablet. I'm using a Apple Pencil, iPad, and I'm using some custom software. It is annoyingly difficult to write on your screen using an iPad and an Apple Pencil. You can write on the iPad, but then you look like this the whole stream. Or you look like this and you have the iPad in a horrendous position. So it's nice to be able to treat the iPad like a graphics tablet if you're doing that type of thing. Getting the iPad to behave as a graphics tablet without horrendous lag, though, is quite difficult. So, I mean, it took me ages to do it, so you may as well have to hear about it. No, I'm right-handed, sadly. Sorry. My father was left-handed. True Odes fans are aware of the saga of my father being left-handed. Anyway, so currently, the custom software is built such that my iPad is loading a web page. The web page is served from a server on my laptop. It is connected directly via Ethernet because Wi-Fi is too laggy. At least my Wi-Fi is. And then it's all WebSockets and stuff from there. OBS is not. This is not a screen share OBS because OBS screen share can't really do transparency very easily. So this is a browser source. The browser source. So I'm looking at OBS right now. Not any other thing. And OBS is also connected. And then there's another one for key presses. So there's another browser for key presses. So then I can use my keyboard, my left hand. This is my left hand. Write with the right hand side, so that my handwriting is a little easier if I can control. So this, for example, obviously if you draw with the Apple Pencil, you would expect a mark to be made, but it's not doing that because I'm not telling it to. This means I can then look at my screen to where I'm actually pointing, like a graphics tablet, and then I can hit the tilde key, which is what triggers the drawing. And I can also do things with different tools, so I can move things, and I can duplicate things, and I can erase things, and I can drag things. Anyway, yeah. So, and the lag probably looks a little bit worse on OBS than it really is. Like, it's pretty tight in real life. If this was 60 FPS, it would look a bit better. But yeah, it was a bit of an engineering project to get all this put together so that it would work. Basically, my inspiration is the actual blackboard. I want it to work basically like a blackboard does, so that I can be a little bit like we're in a kind of room and we have a blackboard and we're not like writing LaTeX or anything where I've got to like, get all the LaTeX right and then it's got to load and stuff. But I can just sort of, reasonably fluently. Obviously, I put in text input because writing things, it just takes a while, especially with proofs. So I put in some text input for that. But yeah, that's the software. Classic software engineer just can't stop making software. Check 94, hello. Exercise 18, which assumptions are we allowed to use? I can't imagine the book expects you to prove it using the definition of the reals. I don't know what you're allowed to do for 18, but when I get there I may know. However, the stuff we've been introduced to in the book so far is, set theory, logic, a little bit of combinatorics, and we're in the chapter about direct proof. So I would imagine we're supposed to use direct proof, maybe including some cases or not including some cases, but I don't know. So I don't think we have a definition of the reals yet. We have talked a bit about definitions of the integers and some of their properties. Yeah. But when we get there, maybe I'll get stumped forever on it. Okay, so we got some cases probably. Probably should try cases for 16. So we're trying to, well, what's our proposition? Come on. Proposition. Two integers have the same parity. Their sum is even. Is it a two integers? It is integers, right? Yeah. A and B. Yeah, we only need to consider the situation in which they are odd and even. And Stucky says, it's a good point that by viewing on the computer screen instead of the device, I could avoid staring at my desk. It feels like that part would take some practice. Were you already experienced with the graphics tablet, with the drawing tablet? No, actually. No, but I kind of knew I wanted to do that. Or actually, I didn't know. I had to think about it. I knew I wanted to look at the screen, but I wanted to use my... I wanted to be able to sketch. Actually, I knew about it after doing a bunch of streams in which I used Excalidraw. And no, actually, you know what I knew? I knew that I wanted to do this because I knew I needed a way to input math text / formulas, but I didn't want to use LaTeX because it's not a very fluent medium for presenting with. It's great for its purpose, but ultimately it's a translation between a root, like a basic form and a presented form. And there's a reason people probably don't just use LaTeX for teaching, they use blackboards. And I knew that my current approach of just using text substitutions was falling apart very quickly. So I thought, well, if people want to present math to a general audience, what do? Well, they use blackboards, right? Almost all the streamers who do math also use a kind of blackboard, which is kind of interesting. There's almost, not many people using LaTeX for that purpose. So there's one streamer who's quite popular. I think there's been a bunch of people in here probably watch streams where she uses Photoshop, I think, for math stuff. And then e to the 2i pi, if that's right, uses an actual blackboard with like a camera setup. So you know, all of this, it kind of involves all of the rest of it falls out of this. Plus, I don't want my neck to hurt. That also helps. Okay, so then let's say, well, actually, we kind of want to think about the result too. Oh, even. This will be even. We want to prove this is even. What's another letter? G? We've not used G for a while. So I guess we can then just set this up. I'm a little hazy on the proof steps here, but let's say 2x plus 1 plus 2y plus 1. Ooh, we're going to have a lot of unknowns here. No, actually, we probably don't need to do that now I think of it. No, that's probably not. We probably come up with it the same way we did the previous ones. Yeah. Yeah, good point, check 94. It did feel a little bit funny to introduce that. Okay. No. And then if we could put this in a form which looks like we could make it in the form of an even number, then would be golden, right? So we can do that. Yeah, and then we can say okay. Let's consider the other case. Don't know why I've done them in reverse. Somebody's talking on the recording. Happy Nora, you're not happy with my lack of. I mean, does he put those in his? I guess that's why I'm not doing it. I'm just copying him. Is he doing that? He's sort of just using equal signs. Oh, I guess, yeah. I guess, yeah, he is using equal signs. That's what you're saying. Just for you, Happy Nora. There you go. This one's a bit more trivial, isn't it? I've kind of used the same symbols, but whatever. Probably shouldn't use the same symbols. Trivial. Okay, I think that's sufficient QEDing. Does it go on the same line or the next line? Why can't I draw a simple rectangle? What is wrong with me? Oh my gosh. Awful. Okay. Now was that one an even? No, that was an odd one. Desiree. Once you're done, are other probably valid demonstration appreciated as other perspective, or do you prefer to avoid receiving extra input? If you have, so there's no particular rules about like if you have an answer or if you want to input anything, please do. I don't mind kind of spoilers. Ultimately, as everyone in the chat will know, I'm not it's yeah, basically I don't mind any spoilers, or even if such a thing could possibly exist. But there's no promise that I will understand what you're saying. But I will try to. If that's what you're asking, I mean. Oh my gosh, we've lost another 200 frames. This is outrageous. Why did nobody say anything? Desiree says, if I can propose a visual solution, let's imagine the lines of numbers as a... Let me sketch this out as we are... It's a visual medium. Imagine the lines of numbers as up, down, up, down, up, down, up, down, up, down, where the higher points are the even. So, like this. Are the even and the lower are the odds. Odds are even offset by 1, so that's true. Oh, somebody's driving. If we sum two odds, we have two evens offsetted by 2, which is even. If we sum two even, we are offsetting an even number by an even value, obtaining an even result. Yeah, that makes sense. We kind of end up with, like, if we were to kind of do this, I guess it might be more... Yeah, so let's say we were taking 3 and 7. I guess it doesn't matter where we start. Maybe it does matter where we start. Or we need to start... confused myself now. Weird. Well, anyway, it kind of makes sense. I kind of hoped it would work more visually. Maybe we need the 0. Oh, we've got a Blahaj lover in here. I saw somebody walking down the street recently with a Blahaj. That's the most public Blahaj I've seen. It was quite something. It's really windy, isn't it? Oh, freezing in here. Oh, it's so cold. Sorry. I really thought that's how you pronounce it. Am I pronouncing it like you pronounce it, Happy Nora? Is it like a... You know, there's... I mean, I'm not really that way inclined, but it is a bit of a cultural phenomenon. I suppose everyone must know, if you're here, you must know about the cultural phenomenon of the Blahaj. Maybe, I guess people might not know if they're not in the know. If they don't know the secret handshake. I mean, I guess other people can like that shark too. Okay, where were we? We did 16. Let's do 17. That's how it works. There's a handshake. Actually, there's not a handshake. There's not a handshake. You don't need the handshake. Okay, if two integers have opposite parity, then their product... Oh, I have to do this again. Product is even. Fine. Alright, let's do it. Prize for anyone who guesses the font. There is no prize, but you get bragging rights. Or you can imagine a prize, and I may decide to grant it if you can get the font right. You do have to get the variant though. You don't like shaking hands, Happy Nora. Do you dap? I've been attempting to learn for the past few years. Ever since, you know, occasionally. It's just something you need to be able to do. Sometimes, especially at the gym, people try to engage you in dapping, and if you just like don't know. The worst one that happened lately was the guy who runs the gym that I go to. He's a very large man, and just imagine the largest man. Just imagine how large the man you think I'm describing is, and he's larger than that. he's like inductively large. He's a big guy. And he also has an accent which isn't my accent. It's not understandable, but sometimes the words are a little bit hard to decipher. Anyway, so this is so awful. He was talking about how my form for a particular movement was good, and then he put out his. Or I think I complimented him on something, maybe how big he was, and he was like, yes. He was like, right. He just kind of went like that, and I was like, cool. He was like, and then after like 5 seconds, he was like, you're not gonna leave me hanging, are you? Because he was going out for like a fist bump, and I was just like, just sitting there for like 5 full seconds. He's just waiting, and then I give him like the weakest fist bump ever, and like his hands are like huge, and you just feel just like as if you were like trying to fist bump God, you know, like Oh, it was so embarrassing. Ah, nice guy though. You're a big dapper, Miloran. Oh, good. Good. Yeah, any tips? It's not monospace. Check 94, you're right about that. It's not... It's not a Vera font, I think. Yeah, I don't know what that is. It's not Deja Vu Sans. It is Sans. Of course. You can tell by the lack of serifs. Okay, Happy Nora's got the answer, so I'm not going to read that until I've had my attempt. Okay. Proof. Right. No, that's not even right. I just totally just made up something. Trying to prove something that isn't true. Opposite parity there. What am I doing? What am I doing here? Not paying attention, that's what I'm doing. Come on. If two integers have opposite parity, then their product is even. That's what we're supposed to be doing. Right. We will consider the case in which the case is where no. What do I need to do the same thing again? What is it like? Consider two integers a and b. We will consider the case in which product is even. No. What will we consider? We'll consider the case in which their parity is wait, does it even actually I guess opposite. We just need to prove it once, right? We don't even need cases. That's why it doesn't say try cases. No cases. Okay, consider two integers, a and b. Let a be odd and b be even. Wow, just like a microsecond lost from the connection. Wow. Huh. Okay. Weird. Anyway, what was I thinking? Yep, there it is again. More tech, more problems. There we go. Okay. Okay. No, wait. More mistakes. More mistakes. Can I get through one thing without making a mistake? No. Product, not sum. Product, not sum. Product, not sum. Okay. 2x 2y plus 2y. We're trying to prove the product is even. So we could extract a 2 here. I guess this is 4y. 4xy, sorry. Yeah, that makes more sense. Okay. Just dropping stuff. Alright, we get to check this one against Richard's logic. We get to go into the Richard verse. What's this guy saying? What's he up to? If two integers have opposite parity, then their product is even. Proof. Suppose A and B are two integers with opposite parity. Thus, one is even and the other odd. Without loss of generality, a phrase that I need to look up again. Suppose A is even and B is odd. Therefore, there are integers C and D for which, yeah. Then the product, yeah. Product. Therefore, AB equals 2k, where the k would be the right letter to use. Yeah, therefore the product AB is even. I need to be a little more rigorous with my use of this, probably. Yeah. Okay. Now he does talk about the phrase without loss of generality. In reading proofs in other texts, you may sometimes see the phrase without loss of generality abbreviated as WLOG. Alright, so he probably defines it up here. Two cases in this proof are entirely alike except for the order in which the even and odd terms occur. It is entirely appropriate to just do one case and indicate the other case is nearly identical. The phrase without loss of generality is a common way of signaling that the proof is treating just one of several nearly identical cases. Right, I see. Occasionally, two or more cases in a proof will be so similar that writing them separately seems tedious or unnecessary. Well, I guess that's what happened in this case, right? So, yeah, alright. So that's what the without loss of generality means. It means... I mean, I don't really know what this phrase actually means, as opposed to just being a magic keyword to say, you know, they're all the same. I guess it means we're still considering the same level of generality. We're not considering just one case. Same level of generality as the initial... Okay, maybe something like that. It means the unaddressed cases, says check 94, can be reduced to the addressed case. It depends on the author how trivial this reduction is. For some trivial reduction is probably advisable. I'm still live, Coding Barra. I'm still live, and you still haven't told me what you lifted. It's driving me mad, not knowing. Okay, how much more are we going to do of this? How much more of this do we have to sit through? Just going on my phone there. Let's finish this coffee. Did I get to the juice inductive proofs yet? No. No. I'm still a way away, actually. We've got to work through contrapositive proofs. Where's the contents? It's a clip-worthy scroll there, I think. I just have to do some calculations. Alright. Contrapositive proof, proof by contradiction, non-conditional proof, proofs involving sets, disproof. Only then may we emerge into mathematical induction. Relations, functions, and cardinality of sets. Now, I think probably I will be able to cover these a little more lightly. Because, I mean, a lot of what direct proof I'm learning, well, a lot of what I'm learning in direct proof is just proofs. So hopefully these will be more techniques than totally new fields of knowledge. But we will find out. Might do just the odd questions or something. Yeah. Okay. Can you believe I read all this? Okay, so we did 17. Let's do 18 and 19. Calculus stream where? Yeah. Yeah, that would be a ride. The calculus stream. All right. I'm gonna treat you to something. I'm gonna treat you to something. I don't usually show everyone this, so. There you go. Yeah, that was me. That was me. That was me going to the basement. Yeah. Yeah. I'm height adjustable. Yeah, another thing that you don't know about me is, you know, most streamers, they have a chair with a back, big gaming chair back, and it looks terrible. You got your whole gaming chair thing in there, awful. I couldn't be me. Anyway, so since probably about 5, 6, 7 years ago, I've used a kneeling chair, a backless kneeling chair, which means I never had to worry about the problem of having my gaming chair show up in streams and messing with my keying. No backrest between me and the green screen. Exactly. Yeah, I need to get it reupholstered though. It's getting a little bit bare. Although it is a good reason to stand up. You're learning a lot about me today. Wow, 1,191 frames now lost. Lost to the ether. Very sad, very sad. Those poor frames, never to be seen. Who knows what could have happened in those frames? Ghosts? Demons? Anything could have happened in them, and we would never know. Well, I guess I won't know. Okay. 18. Suppose. Ah, this is the one that somebody was remarking on as a bit. Well, we'll find out. Possibly challenging is how I interpreted that. Ah, Happy Nora. Happy Nora. I think you got it. Now, technically, it's IBM Plex Sans condensed, but I will give you that as an impressive find on the font. Yeah, that's pretty good. How did you do it, Happy Nora? What was your share your font stalking techniques with us. Okay, suppose x and y are positive real numbers. If x is less than y, then x squared is less than y. Okay, let's try this out. I think this was even an example, I think. I think we're being given this to check we read the material. Now, my instinct is just to do this. You don't have the condensed one. Yeah, the condensed ones are a separate download. Condensed, I chose condensed because more text on the screen, and you know, screen real estate is premium. I only have so much, you know, so don't even have enough for my arm. But the IBM Plex series is one of my favorites. It's not my brand font for Odes. The brand font there is Monospace Xenon, however that's pronounced. But I do like IBM Plex. I did use it as my editor font for a while. And when we get to math fonts, I kind of think, honestly, now this is going to be a bit of a spicy take. I kind of think the whole sans serif math thing, it's a bit played out. I just feel like, sorry, the serif math fonts thing is a bit played out. It's just a bit, it's a bit you're printing a book, right? I just feel like if you're doing math on the screen, why not use sans serif? Okay, so is this done? Is that just it? I mean, my instinct is to think about situations in which, well, actually they're both positive. So I mean, what's wrong with this? Isn't it just proven now? What means it's not proven? I just feel like this is, I can't see what's wrong with this proof. Oh, I guess it, you know, it's, I mean, I guess I'm saying, between these. Lauren says there are a few different ways to show it. For instance, X, Y, X. So we multiply both sides by X. X squared. Oop. Y squared. Check94 says what you've written here is if x is less than y, then x squared is less than y squared, which is just a restatement of what we wish to prove. I guess that's true. So what is it saying? We need to go to a deeper level of detail on this or something? Because I guess I would take that as a... I guess we don't have anything like... I guess, is it this operation that's the problem? Like, I guess in terms of what the book has given us so far, we haven't been given power as anything we can use in the proving process. So if I was trying to formulate, like if I was... I guess if I was trying to... I guess I just view this as an obvious step, but I guess it's not an obvious step. Right, let's look at this idea some more. So Millerin had this idea. So in this way we're multiplying both sides by x. Oops. And then there's like an extra step here, which I didn't quite get with from Millerin's message, but maybe Happy Nora explains it. But the next part is, well, we know the left part is x squared. The question is then, how do we get y squared? And I guess if x is less than y, then as Happy Nora says, xx will be less than xy, which will be less than yy, because x is going to be lower than y. So it's always going to be less than the product of a number and a lower number. Sorry, a number and a lower number is always going to be lower than a number and that number. Like you're basically kind of saying x multiplied by y, sorry, no, x, sorry. You're basically saying x, sorry, oh my gosh, y multiplied by y minus, what's the epsilon thing? Is that epsilon? A tiny, tiny thing. I mean, this is, I guess, completely unsound. Is going to be less than yy, which means that the, you know, the boundary, the most x could be would be like this, right? I mean, this is very shaky, but I guess that's the logic. And then likewise for this. I suppose. And then you've got that. Interesting. Thank you, Happy Nora. Thank you, Lauren, for putting that one in the chat. Check94 says, one of the things to do here would be to define squaring and show the result follows from the definition and whatever other theorems you're allowed to do. xy is less than yy is also just the result of multiplying by y on both sides of x. Oh yeah, I guess that's also true. Wow, that's even easier. Pleasing. Okay, so right, so okay, so from why is this horrible notation over here in my life? Okay, so then xx no, that's not right. So we get x is less than y, then we get xx is less than xy. And then we could do oh right, I get it. I get it. Is this a notation? Is that valid notation? Okay, so then we get both. And these are, you know, linked. So we get, right, because we've got x, y in both. And so then we can say, right. I see. I see. Cool. Cool. Right. Well, that's a bit concerning because that was question 18. So question 19 is going to be kind of, I don't know. Sometimes they're kind of paired up like that. Alright, let me charge one of my earbuds. I'm using the other one. Okay. You know, I think we got to get to... If X is the leg and Y is the hypotenuse, we can use the Pythagorean's theorem to prove 18, I think. Ah, nice idea. If only I have to wait for the trigonometry stream for that one. Though I do happen to remember Pythagoras' theorem. Okay, so I'm going to try and complete 20. That's what I'm going to try and do. That's my goal. That's my goal. Okay, so 19 first. Suppose A, B, and C are integers. If A squared divides B and B cubed divides C, then A to the 6th power divides C. Okay. And just write this out as well in a non-horrible form. A squared divides B and B cubed divides C, then I guess that one. I forget exactly if I want to use the stronger one or not. I guess this one should be sufficient because it includes the larger one includes it. A to the 6th power divides C. Okay, interesting. Okay. Suppose one I guess by definition of divides, it's something like, what is it? Let's see if I can dredge this out of my memory. There exists a, let's go with X. No, there exists, it's something like this. Or is it the other way around? No, it's the other way around. It's B equals A X. Yeah, so there exists some X that you can multiply by this number, which will obviously be not these actual symbols, to produce B. Okay, but obviously all these symbols are not right, so it's actually going to be B equals let's go with X, I guess. Yeah. Now, I was just wondering if this is true for for this, but it's not implied, actually, because it's obviously not implied. Well, actually, no, it is implied. Yeah, no, it must be, but maybe it doesn't matter. Okay. Well, let's just mess around with this, and then let's suppose 2 also. What do we get? We get b cubed divides c, so we get c equals y b cubed. If you can hear this, it's kicking off outside. Sadly not. Okay. And we want to end up with, we want to show that no, we want to show that C is equal to something times A to the 6. That's what we want to get to. But we shouldn't be using it yet. Okay, so can we just substitute in C equals Y x A squared cubed, and this gets us I guess it works like this. And then we can get rid of this, these brackets. So that's a Z. Are we done? Therefore, let me just write this out. Okay, and what does this need to be in the space of? I guess this needs to be in probably the integers. Yeah, let's just put this on everything. We'll see what Richard does, and then we kind of know that already. Whence 3 follows by definition. Cute. Miluran has it different. Oh, you didn't do the substitution. Oh no, you did. It's just, you did. You just, yeah. Sorry, I get it. YX rather than NM. Have I seen the Lang UI UA? No. I haven't. Is it good? Tacit array programming language. It does look cool. It's like an APL type language. Looks like kind of would make sense. Let me put this in my my special window. Where am I? Where am I? Where am I? Yeah. UI UA. Huh, you know what I like? I like the symbols. Neat. Oh. Cute. Very pretty language. Yeah, this would be fun to stream at some point, wouldn't it? Put that on my stream list. Nope. Yep. Wherever my stream list is. Thanks for the hint. Or recommendation. Whatever I'm trying to say. It does look fun with all the symbols. Need a special keyboard. I do have, you know, all this heat has, because of course I don't really want to have my hands on my laptop because my laptop is 1000 degrees, aka 74 degrees. I have an external keyboard, split keyboard somewhere. Kind of tempted to dig it out. Unfortunately, I was feeling hubristic. You know how we are, us humans, with our hubris. Anyway, I was feeling hubristic and I thought, letters on the keyboard? Characters on the keyboard? I don't think so. It looks kind of cool to not have the symbols on the keyboard, then you can remap them to anything else. And I know where the letters are on the keyboard. So can't fucking use it, obviously. Like, just tried to use it. Just like I was 100 years old. Like I'd never used a computer before. Anyway, so I never used it. I actually bought it accidentally. I tried to quit out of it and then I accidentally paid for it. It was it's an embarrassing moment for me. Anyway, maybe I'll dig it out again. Okay. That was 19. What does Richard say? What does our friend Richard say? Did he link the quote? No, he didn't. That would be cool though. 19. Suppose 19. Suppose A, B and C are in the integers. If, etc. Proof. Since A squared divides B, we have B equals KA squared. Need to use K more. For some K in the integers, since B cubed divides C, we also have that. Thus, what we did, thus, hence. Oh, you know, I forgot. Forgot my little box. There we are. QED. Okay. Now, final question. Thank you. Thank you, Happy Nora. I imagine the questions have gotten easier. I think Richard's difficulty curve is a bit like it's a bit like this. So the most difficult questions, at least in my opinion, are around the middle. And maybe there's some like there's like a crazy one at the end. Speaking of the ones at the end, you know, I finally figured that problem out. I did stream it, but I figured out a much better answer. You know the one with the sphere? So the question was, let's say we have a sphere. Just imagine this is a sphere. You've seen a sphere before, right? Now we position 5 points randomly on the sphere. Show that 4 of them, show that there must exist a hemisphere of the sphere which contains 4 of them. That's the question. That's the question. So the hemisphere is defined as you take your sphere and you draw a line or something that divides it into 2 or something. And he defines it better than I am, but and you take that golden circle, I think he called that, and you union it with one of the halves, and then you have your hemisphere. So crucially, anything along the hemisphere counts as part of the hemisphere. So when you position your points, which it's easy to see with a circle, honestly, it works with a circle as well. Let's say you start your point here, and let's say we have a point here. No matter where it is on the sphere, I think, I can't prove it, but I think you can draw a line between them that divides the sphere in 2. Let's say. Is that true? I think it's true, but I feel unconvinced by it now. But let's say with a sphere, any 2 points on the sphere, you can draw a great circle through them. Now, because the points are on the great circle, because we've defined the great circle that way, those 2 points are in both hemispheres. So they're in both, doesn't matter. Then, no matter which way we select our points, the remaining 3 points, let's say we try and position them here, and here, and here. So now we have all 5 points in one hemisphere. Let's say we move one here. We've still got 4 points here. So let's say we really mean and we try to move one out. But now we've got 4 points here because we've got the points on the hemisphere, on the great circle itself, plus the points in each hemisphere. So this is like the pigeonhole principle, where the pigeonhole principle comes in that if you're dividing, let's say you've got your 2 parts. If you're needing to distribute 3 points into this zone, into this area, into this sphere, then there's no way you can have an area like a hemisphere which will have fewer than 2 of them. Or sorry, like there will always be something, something, something. There will always be one of the hemispheres with 2 in them, at least. It could have one with 3, but there'll always be one with at least 2 by the pigeonhole principle, etc. So at first I had a more complicated version of this where you have to like draw a triangle or something, or some craziness. But actually it's even simpler than that. You just define the great circle as being on the first 2 points you put, and then you end up with something that works. Anyway, so that was kind of cool. That one kind of sat with me for a while. Anyway, so that was an exercise way back ago. Okay, 20. Let's do number 20. And let's get rid of all this highlighting. Well, let's get rid of all of the highlighting apart from these, which I'm going to come back to. Let me highlight. No, I don't want that. Oh my gosh. Why can't I do anything in my life? That'll do. What if all 5 points happen to end up on the great circle? Well, in that case, you're okay because they both have. Checkmate. They both have 5 in there. I thought that was kind of sneaky how he defined the hemisphere to include the central point, the central circle. Okay. 20. 20. Come on. There we go. Right. If A is an integer, oh my gosh, come on. A is an integer and A squared divides A, then A is a member of Am I using tiling or is that Emacs? There's no Emacs here. But I don't quite understand. I guess why, yeah. If it answers your question, all of this is just OBS and browser sources and screen shares and stuff. Although feel free to rephrase. Okay, so okay. So it's kind of intuitively makes sense that this would be true. I guess we can look at Can we prove it though? Okay. And then we've got I guess it's probably one of these. Is it one of these? Maybe. It's equivalent to if let's say can we do this? Is this anything? Is this anything? Is this anything? Yeah, so we're like subtracting off. Yeah, I need to not get my X's and my A's mixed up. Now, in that case, can we put this in some sort of form that we're familiar with? XA squared. Right, I'm going to change this X to something else. This X is confusing me. Let's go with G. No, let's go with K. But no, K is hard to draw. Let's go with G. Okay, so we got that. And then we got plus A. And then I guess plus this. Can we do anything with this? Does this turn into anything? It's got to be a... No, we can actually get rid of this. Get rid of that minus. Okay, then what can we do? We've got A, and then there's some rule for this. Well, maybe there's some way of doing this, but I'm not quite sure what it is. I guess we could use the quadratic formula maybe? Doesn't seem like it's going to pan out. Kind of... I don't know. Let's try it anyway. A lot of symbol manipulation going on in my head right now. Okay, so with this, we've got... What have we got in here? We've got... All this turns out to be 0, because we got 0. So it's the root of 1. Which, of course, is just 1. Minus 1 plus or minus 1. Over 2g. So that's going to end up being either minus 1 plus 1 over... Assuming that g, of course, is non-zero. We don't know if that's true, I guess. Are we told this here? Not necessarily. We'll need to think about the case in which g is 0. Yeah, or we've got minus 1 over 2g. Not sure I'm getting anywhere with this. Okay, minus 1 plus 1, that's 0 over 2g. Or equals minus 2 over 2g, which is going to be minus g. And this is going to be 0. So x is 0 or x is minus g. Is this anything? Now, if x is 0... Oh, by the way, x is not right. X should be a. Yeah. We're looking for the solutions to a. Not x. If we plug that in here, what do we get? We get... Yeah, so we got a... What's this G thing even? I made a mistake again. You're saying it's a minus A. Oh, yeah. Because I took the minus out. Yeah, that's foolish. Can we do any better with this? Can it be factorized? I don't think so. I think we can factorize it, if that's even the right word. Okay, quadratic formula again. Quadratic formula again. -1 Plus or minus? No. Yes. -1 squared, which is 1. It's still going to be 0 because C is still 0. And we're still going to be having G be our A, so it's 2G. And this is what A is going to be. They're saying +1. Oh, shoot, yeah, double minus. Yeah. Yeah. Oops. Need to stop making errors. That's why I'm a programmer, though, I suppose. Back into the world of programming, I won't have to deal with all these mistakes I keep making. Or maybe I'll just get better. Maybe I'll get good. Okay, so in now root 1 is 1 anyway, so we get 1 plus 1 or 1 minus 1. Again over 2G. This one's going to end up being 0 over 2G, which of course is 0. And this is going to end up being 2 over 2G, which of course will be G. So what's G then? So A is either going to be 0 or G. Well, I guess that is useful to know. A equals 0 or A equals G. Now, can we plug this into anything earlier? Yes. So we've got A equals... Well, what we've got is, for example, 0 equals... This is a bit messy, but 0 equals G 0 squared, in which case G equals 0, or A equals G, in fact. In which case, G equals G. What is this? 0. And then G. I made a mistake again. A is 1 over G. Oh, yeah. Because G's on the bottom. Right. Right. Okay. Come on, don't get lazy. Now, if you square something like this, Yeah, you get G over G squared, and then you get G over G squared, which is going to be, if you cancel out one of the what happens in this case again? This is the same as saying this, which means we get to cancel out one of them, right? Does that just mean we get 1 over G again? Not very satisfying. One over G must be an integer though. True. Can't be 0. I guess it's going to be a positive integer. Maybe. Maybe. Yeah, maybe there's something in that. What is the actual rule there? Has to be an integer. Doesn't have to be positive. I guess A has to be an integer. So if A has to be an integer, in euros here, if A has to be an integer, it limits our options, right? So I guess that means it has to be this or this. Can't be that. So I guess this gets us like well, we know A equals 0 already, so we don't need to worry about any of this nonsense about G being 0. So we get that G is we get that A is either of these, don't we? That's what we're doing all the way over here. Right. So all of this gets us that the solutions for A are either 0 or 1 or -1 through all of this, which would make sense. And that's in some way proven. Okay. Check 94 earlier said, my quadratic formula seems a bit overkill. I agreed, though I couldn't see another way of doing it. A minus GA squared and 0 all have A as a common factor. Right, so it's like yeah, the 0 tripped me up, but you're right, obviously 0 we can imagine 0 is 0A, right? So we can consider that to be a factor. Right, okay. And then in this case, A has to either be 0 or A is 1. I don't see how we get -1 though. I guess it... if it was -1, -1... Except that part where you divide it by G. Oh yeah, I just missed out the G entirely. What was I doing? Yeah, just tired brain. That's probably it. Alright, so A... GA... No, wait. What am I doing? What's the actual version of this? Yeah, we could extract A, and then we would get G... No, we would get GA minus A equals 0. But we'd still have this G causing problems here, right? Right, so if we think about the situations in which this is going to be 0, either A is going to be 0, that would work, or I guess I can sort of see that if A was 1, then we'd have A minus A, which would be 0. Or if A was -1, then we'd have minus A. Yeah, we'd end up with -1 minus -1, which would be +1. Which would also be 0. And then you just got to happen to know that no other values of G are going to end up with this working, which I think is probably obvious, but not obvious to me. But I'm sure you could prove it. I guess if we're saying if we're saying GA minus A, if we're saying all this, then maybe we could do something weird. I don't know, do this goes anywhere. Yeah, then either A is 0 or G minus 1 is 0, which means that G would have to be 1, and then we'd have, plugging this all the way back in, we'd have A minus A equals 0, which would be 5. I don't know. I made a mistake. Happy Nora, no. Can't even see it now. Oh yeah, true. Yeah, because we extracted that. Gosh, this is just diabolical, isn't it? Yeah, so in that case, yeah, A's got to be 0 or GA minus 1 has got to be 0. And then maybe out of this we could get something. This would have to end up being 1. And given that both these are integers, we've only got a few ways for that to be true. They could both be minus 1, or they could both be 1. Yeah, that's the only way that could be true. And that would mean that A was either minus 1 or 1. I see. Okay, so that's another way of getting to it. Interesting. Thanks for the tips, everyone. Thanks for helping me pick up my obnoxious mistakes as usual. I'm not going to write this up. Just imagine I wrote it up. So, but just to go back over this. Now, the reason this works, the reason this proves anything, is we are supposing A squared divides A, and A is in the integers. By definition of by definition of divides, we know that this is going to be true. Therefore, we also know by rearranging this and also this, And we also know this. By definition, yeah, and then by rearranging this, we also know this to be true. Then we do a bunch more rearranging, and we get to this form. So we know that we can say that there's a quadratic equation here, which means since there's a quadratic equation, we've set it equal to 0, we can work out what the possible values of A are going to be. And we can do that in a number of different ways. We could do it with the quadratic equation, or we could do it, what's this called? Is this factoring? I guess this must be factorizing. Maybe that's what it's called. And then we need to do a little bit of extra reasoning. I guess one thing I've learned today is all of this nonsense. So the way I learned all of this type of quadratic algebra stuff is, okay, so I mean it's kind of very British schooling, unfortunately, and I don't think it was against my teachers exactly. I think I just probably didn't, I don't know, I just don't think I got what they were trying to sell me, because they did spend a lot of time driving this stuff and it was cool to listen to, but I don't think it helped me. I don't think I took the right thing from it. But basically, my understanding of how you solve these quadratic equations is there is a formula, but the formula's kind of basic. It's kind of old and busted. You know, we don't like the formula's no good. Formula just if you're weak and you can't do the strong way. And then if you're a genius, you can do this. And you can just magically come up with whatever the numbers are. And something, you know, just magically know, just sort of mentalize it all, and then you know somehow from these numbers what all this is about. Somehow these numbers tell you something about what the values of X can be. And I had a vague notion from last week that there was something about this being set to 0. I wasn't like 100% sure if this could be done for inequalities, but I guess it can. I think I did know, but didn't quite remember that you're talking about situations in which either of these terms can be 0. Therefore, you need to do a bit of backward thinking and say, actually, X would have to be 2 for this to be 0. X would have to be -4 for this to be 0, and this tells you the possible solutions of X where this whole thing is 0. So I kind of solidified that, and then I guess there are, what I viewed previous to the last couple streams is all of this business. It's like a bunch, you know how they teach, well, at least they taught me integration. They were like, by the way, you know, if you have this, you basically, you get this if you differentiate it. I think that's right. Don't quote me on that. But who knows why? It just is. And I think I saw this in the same category, and I think Namer actually picked up on this earlier. I didn't really know what I was doing. But I guess if you do view it as more of a problem solving where you're trying to work out what values of X will set this to 0, you can be a bit more creative about it and think about what situations in which something more complex like this thing here can be set to 0, which is when this is 0 or when this term is 0. What would it take for this to be set to 0? Well, you know, we could work that out sort of in this way, and come up with another argument. But I don't think I had the understanding really of what all this was about until today, to be able to use it more flexibly. And I still barely do, but I'm closer. You're very welcome, Happy Nora. Thank you for hanging out. Climbot says, when you've seen enough of them, it's easy. When you multiply two real numbers together or integers, you can only get 0 if one of them is 0 already. This is the property of an integral domain. Cool. Great. Okay, we got to 20. Now, I may, you know, I'm kind of tempted to do another game stream this weekend. What do we think? They say you should do what your audience comes here for, but you know, it's just kind of fun to do game streams sometimes. Do any of the attendees here have any thoughts on whether game streams are a good or a bad idea? Or whether it's kind of funny to see my windows do this, just occasionally? Do you like that? Alright, let's see who's around. Resize Windows stream, yeah! Whoa! Crazy. Alright. I'm afraid to tell you we've lost 0.1% of the frames on this stream. Means we've lost about 2,000 frames. I'll try and make up next time, make up for the lack of frames. Somebody's streaming with the tag feet. Not sure. Not quite sure why that is. Okay, each of the two iPi was streaming for a bit, but I think he stopped. In the software tag, I was gonna raid the person who tagged their stream feet, but I saw the tag feet. I was like, oh, I don't know. I might regret that. Just end up like you join the stream and the face cam just pivots to feet, just the feet cam. Let's go check out. Actually, is there anyone on the who's got math right now? Let's see if there's any math tagged. We know what you come here for. There's nothing. No wait. I'm coming. I'm getting there. It's happening. Oh my gosh. Please, Twitch. Okay, right, great. Oh wait, you know who it is? It's our favorite participant in Stucky. Let's get right in Stucky. Alright. Very exciting, very exciting. Okay. Have fun rest of your days, everyone. We're gonna be raiding in Stucky. And yeah, be good. I know you will be. Laters.